Howdy class. Welcome to your video note lecture over variables and expression notes. We're going to talk about a little vocabulary to begin with. The first one is variable. It's a symbol, usually a letter, which represents one or more numbers. It's just a placeholder. It could be any letter, as like S, it could be Z, it could be N. We have been using N lately. It's just a placeholder. Next one's a mathematical expression. It consists of numbers, variables, and operations. And remember, an expression does not have an equal sign. That's important to remember. It does not have an equal sign. And evaluate, of course, that's the same thing as solve. So, and then we're going to go down to addition. You guys need to learn some of these words so they can trigger what to do when you're reading these word problems. So addition is the same thing as plus, the sum of, increased by, total, more than, or added to. All of those mean you're going to add. And subtraction, you could use minus, the difference of, decreased by, fewer than, less than, or subtracted from. Remember, when you see these keywords, it should trigger in your mind that we're going to do subtraction. Multiplication, times, the product of, multiplied by, twice. You can also see quadrupled, tripled, anything like that should trigger again that you're going to multiply. And division is just the opposite of multiplication, to be divided by, the quotient of, separated into equal parts, or it could also say divided to. So remember, when you see these keywords, it's going to be either division, multiplication, subtraction, or addition. All right, so now we're going to take a look at some examples. So the verbal expression says the sum of a number and 10. So a number can be any letter we want to. We're going to use the letter N. So the sum, if you refer back to your vocabulary up top, means add. So it's going to be N plus 10. The next one says the difference of a number and 21. Again, the difference of a number. Difference is going to be subtraction. A number can be any number out there, so we're going to signify that with N, and we're going to subtract 21. The next, the product of 6 and a number. Again, the product signifies multiplication. Again, any number, we'll use N again, and we're going to multiply that by 6. Remember that numbers are more important than letters, so we're going to put that in front of the N. We don't have to put any sort of sign in between numbers and letters because it always signifies multiplication if there's no space. You can also put it in parentheses if you choose to, so you can see the designation for multiplication. The next one, the quotient of 48 and a number. Quotient, that big word that everybody loves to say, means division. So we're going to divide 48 by some number, and we're going to signify that as N. The last one, 1/4 of a number, everybody's favorite thing in math, fractions. We're going to take 1/4 of. Of always means multiplication. So we're going to write 1/4 times N. Again, you could either put it in parentheses or not, but if there's no space, it signifies multiplication. Order is also important when translating subtraction division expressions. The difference of a number and 6 is represented by N minus 6. It says the difference of a number and 6. So the number comes before 6, so your variable is going to come before 6. 4 less than a number is represented by N minus 4. Again, it says 4 less than a number, so N minus 4. Since it implies you have a number first, then take 4 from that number. The quotient of a number and 10 is represented by N divided by 10 or N over 10, however you choose to write it, not 10 divided by N or 10 over 10. Again, the quotient of a number and 10, the number is listed first, so we're going to write it first when we write this out. When representing multiplication in a number and a variable, the number is written first, followed by the variable. Like we discussed earlier, numbers are more important than letters, so they're always going to go first. So for an example, the product of n and 3 will be written as 3 times n, or 3n. All right, class, if you flip your page over, we're going to look at some math relations now. It says, complete the sections below to represent the following situation. Sally paid $7.50 for 5 blank CDs, and we need to know how much she paid for a dozen. So the information given to us, it says that she paid $7.50 for 5 CDs. So I want you to number your graph there, or your chart. 1, 2, 3, 4, 5, 6, 12, and then n on the left-hand side, because we're also going to get the rule, because we've been practicing that. So the cost of 5 is $7.50. So we need to find out how much 1 costs. If you remember back from earlier lessons, we set up a proportion. So we're going to do the CD over the cost. So we pay, I'm sorry, take that back. We're going to do the cost of the CD over the number of CDs we get. So $7.50 over 5 is going to be equal to some number, we're going to call it X, over 1. So, and also, like we learned earlier, cross products are equal. So we're going to multiply the 5 times X, and we're going to get 5X. And then we're going to multiply 750 times 1, and we get 750. Now, we need to find out how much 1x is. We don't need 5x's, so we're going to divide both sides by 5. If we do that, the 5's cancel, and you just have 1x, and then 750 divided by 5. I give you a second to do that. It comes out to $1.50. So now we know how much 1 CD costs. So if we need to know how much 2 CDs cost, we would just multiply the $1.50 times the number of CDs, which is 2, and that'll give us $3. Then we keep going. $1.50 times 3 is going to be $4.50. 4 CDs, $1.50 times 4 is going to be $6. So we already have 5, but we can also write the process. $1.50 times 5, of course, is $7.50. So I'll let you go ahead and do 6 on your own, and we're going to move on now to 12. So we're going to do 12 CDs, or $1.50, sorry, times 12 CDs, and that's going to give us a total of $18. So now we have a difference, it looks like, of $1.50 between each row of CDs. So that's going to be the multiplier in our rule. $1.50 times some number n, and then we're going to plug 1 back into that expression. See, 150 times 1 equals $1.50. That's how much 1 CD costs, so we do not have to adjust it up or down. So our expression will just simply be $1.50 times n. All right, for the written description, basically what we're going to look at is, it says that Sally paid $7.50 for 5 CDs. We need to find the cost of 1 CD. So we're going to label our cost as the letter. All right, so now we're going to work on the written description / equation. If you remember earlier, I said that expression is a mathematical sequence or a sentence that does not have the equal sign. Well, an equation, on the other hand, has an equal sign. So what we're going to say is y equals $1.50 times n. And again, n is the number of blank CDs that I wish to purchase, and y will give me the output once I put the output or the total cost of those CDs. So again, y is the total cost of the CDs, n is the number of CDs, and the $1.50 is my multiplier, or the cost per blank CD. So now what we're going to do is we're going to refer back to the top, And the number of CDs is going to be our X value, or our input, and the cost of CDs in dollars is going to be our Y, or our output. So if you remember earlier, one CD cost $1.50. So we're going to put the number of CDs on the X-axis, and then the cost of the CDs are going to go on the Y-axis. Remember, Y goes up and down because Y can catch rain. So we're going to do 1. We're going to go over 1 and up $1.50, or 1.5. Then we're going to go over 2 and up 3. Then we're going to go over 3 and up 4.5. Then we're going to go over 4 and up 6, and so forth. You can see that we have a fairly straight line there. So, and then it says write an ordered pair for the table and write the ordered pair what it represents. So, for simplicity's sake, we're just going to pick the very first one. So our X value is 1, and our Y value is $1.50. So what does that represent? It says that the price of one CD is $1.50. So if you would have chosen $2 and $3, for instance, that would represent that 2 CDs cost $3. Okay, remember the horizontal axis is your number of CDs again, and your vertical axis is your cost, total cost of the cost of the CDs. Then at the bottom, last 2 questions. What do you notice about the pattern in the process column of the table? Well, it looks like that the $1.50 is consistently multiplied to N, so it's a constant rate of change of $1.50. Remember, constant rate of change, it changes the same amount every time. So every time we buy an extra CD, it costs us $1.50 more. Question B, what do you notice about the shape of the data in the graph? The graph is linear. It looks like a straight line. It also contains the origin. It goes through 0, 0, because if we buy 0 CDs, it costs us $0. Another little tidbit, if it goes through the origin and it's linear, then it's also proportional. That's something else that we studied, because we did set up a proportion to find out how much one CD costs. So if there's anything else left on the page, go ahead and finish it. This is Mr. Sawyer, Miss Charles. Hope you enjoy the video. If you have any questions, go ahead and bring those to class. Have a great evening.